Hello, learners. This is Janet Aves, your broadcasting professor in statistics and probability. Before we begin with our lesson today, please do the following. Make sure that you are seated comfortably in front of the television in a place you will not be disturbed for the next 30 minutes. Prepare a pen and a paper so you could take down notes, and then prepare a glass of water near you so you could take a sip whenever you feel thirsty. Listen well to prepare yourself for a quiz after this lesson. After this lesson, you as learners should be able to first illustrate the probability distribution for a discrete random variable and its properties. Second, compute probabilities corresponding to a given discrete random variable. And third, construct a probability histogram. Previously, we talked about discrete and continuous random variables. Now, what's the difference between them? A discrete random variable has values which are countable. It can be finite or countably infinite if the counting process has no end. In a continuous random variable, the number of possible values is infinitely uncountable. And they are typically measurable quantities such as height, weight, time, distance, and depth. Now, let's explore discrete probability distribution. A discrete probability distribution is a table of values that show the probability of any outcomes of an experiment. For example, when we toss two coins, one after the other, we'll have 4 possible outcomes, which are HH, HT, TH, and TT. Tabulating this to illustrate random variable X, which is the number of tails, gives us possible outcomes, value of random variable X, the number of tails. For HH, 0, HT1, TH1, and then TT2. Now, we will get the probability of the value of the random variable X. In the case of no tails, we have one outcome, which is HH, that is head-head. And getting the probability gives us 1/4. The denominator being 4 because we have 4 possible outcomes. For one tail, we have 2, which are HT and TH, which gives us a probability of 2/4, or when reduced to lowest term is 1/2. Okay? Finally, for 2 tails, we have 1, which gives us a probability of 1/4. Number of tails, no tails, 1 tail, 2 tails. So the probability is 1/4, 2/4, which is equal to 1/2, and then 1/4. Now, if we toss 2 coins together, we will only have 3 possible outcomes, which are HH or head-head, head-tail or tail-head or HT-TH, and TT tail-tail. This is because it would be impossible to distinguish a head-tail outcome from a tail-head outcome. So in that scenario, the all outcomes will have equal probability of 1/3. Another example, construct a probability distribution when we roll a die. Okay, so we know that a die has 6 sides. So what are our possible outcomes? We have our elements ranging from 1 to 6. So the sample space would be 1, 2, 3, 4, 5, and 6. Now, the probability is therefore, the probability of x is greater than or equal to 1 or less than or equal to 6. So what is the probability of getting those possible outcomes? What is the probability of getting a 1, 2, 3, 4, 5, and 6? Each outcome gives us a probability of 1/6. Since there are 6 possible outcomes. Therefore, the probability of getting a 1 is 1/6. The same with 2, 3, 4, 5, and 6. Each of the possible outcomes will give us a probability of 1/6. So, now let's go back to our first example and explore the properties of discrete probability distribution. So we have the number of tails, no tails, 1 tail, 2 tails. So we have the probability of 1/4, 1/2, and 1/4. These are 2 properties of discrete probability distribution. The sum of the probabilities is always equal to 1. We have 1/4 plus 1/2 plus 1/4. The probability is equal to 1/4 plus 1/2 plus 1/4. Is that equal to 1? Yes, it is. Therefore, we can say that this is a discrete probability distribution. Okay, let's go to the next property and see if our example still stands. Probabilities should be between 0 to 1. The values in our table should therefore be equal or greater than 0 or equal or less than 1. If the values are less than 0 or greater than 1, it is no longer a discrete probability distribution. So, remember those 2 properties of discrete probability distribution. The sum of all corresponding values should be equal to 1. And the values should be between 0 and 1. To show the relative probabilities of all outcomes in the form of a graph, we make use of a probability histogram. Let's look at another example. Suppose a pair of dice is thrown. Now construct the probability distribution and draw the histogram. This table shows all possible outcomes. We can see that our sample space has 36 elements. We have die A and die B. When we toss die A and get a 1, and then also get a 1 in die B, their sum is equal to 2. When we toss die A and get a 1, and then get a 2 in die B, their sum is equal to 3. How about when we toss die A and get a 2 and then get a 5 in die B? What is their sum? Correct. Yes, it's 7. Now, what is the highest sum of all the possible outcomes? 12, which is obtained when we get a 6 in both die A and die B. The discrete probability distribution is shown in this table. the range of the variable x being from 2 to 12, that is, the probability is greater than or equal to 2 and less than or equal to 12. Now, as we can see, there is only one outcome that has a sum of 2. And that is when we get 1 in both die A and die B. Since there are 36 possible outcomes, our denominator is 36. Therefore, the probability of getting an outcome which has a sum of 2 is 1 over 36 or 1 in 36. We get the sum 3 when our outcomes are 1 in die A and 2 in die B, or when we get 2 in die A and 1 in die B. Since there are only 2 outcomes which has a sum of 3, the probability therefore is 2 over 36. How about outcomes with sum of 7? There are 6. Which is the highest number of outcomes? Can you identify them? So we have a 1 in die A and a 6 in die B, a 2 in die A and a 5 in die B, a 3 in die A and a 4 in die B, a 4 in die A and a 3 in die B, a 5 in die A and 2 in die B, and finally a 6 in die A and a 1 in die B. Our probability, therefore, of getting outcomes with sum of 7 is 6 over 36. The probability of each discrete outcome is called probability mass function. Now, it's time for us to construct a probability histogram. The histogram shows the probabilities of each outcome. The x-axis contains the sum of each possible outcome, x. The y-axis is the probability or frequency that each possible outcome occurs. When we try to convert the fraction to decimal, we have this graph. Now, let's use the same example. Find the probability of getting a sum of 4 to 6. The probability of getting a sum of 4 to 6 is obtained by adding the probability of getting a 4, 5, and 6. So adding their probabilities, we have 3 over 36 plus 4 over 36 plus 5 over 36, which is equal to 12 over 36. And reducing that to lowest term gives us 1 over 3 or 0.33 in decimal. That means there is a 0.33 chance of getting a sum between 4 to 6 when we throw a pair of dice. Okay, now, try this one out. What is the probability of getting a sum that is greater than 9? The probability of getting a sum that is greater than 9 is obtained by adding the probability of getting a 10, 11, and then 12. Adding their probabilities, we have 3 over 36 plus 2 over 36 plus 1 over 36, that gives us 6 over 36. And again, reducing that to lowest term gives us 1 over 6 or 0.17 in decimal. That means there is a 0.17 chance of getting a sum that is greater than 9 when we throw a pair of dice. Okay? So, that concludes our lesson for today. Again, this is Janet Aves, your broadcasting professor for statistics and probability, quoting the great mathematician Pierre-Simon Laplace. Probability theory is nothing but common sense reduced to calculation. See you in our next lesson.
If there are important points that you want to take down notes or part of this lesson that you missed, you can always press pause or play back on the remote control. Please note that the answers for this test should be written on a piece of yellow paper. Students may opt to maximize the use of their yellow papers by writing answers for other subjects on the spaces available. Kindly note that the same format in texting will be used, and the submission of answers will be on the day of USB swapping. For the format of the answers, please take note of the following format.
Are you ready now for your assessment in statistics and probability? Given the probability distribution of an experiment, answer the following questions. Number 1,